After the revision of standard form of a quadratic function on page 1, you should have a very good understanding of the meanings of a, b, c. Now we come to another format which we call Vertex form in quadratic function, which helps you to have another idea of quadratic. So sometimes I call it AHK form because the format composes of a, hk in the function. So for hk, so you should have some idea about it because it is a notation which we would like to talk about the vertex of a quadratic function. So for example, like if you have a function called y is 2x squared plus 5x plus 2, if we have some ways to change it into a vertex form, so that means it's like 2 times x something squared, which is in the format of minus h and k, then we can know the very important idea about the function. It would be a happy graph because the value of a carries, the values of a is 2, and then hk, which stands for the vertex, which is also the minimum point. And from the minimum points, you can also read the value of the minimum value of the function, which is the value of k. You can also go home and try the software called GeoGebra, which is available in the website, web version, and also in the App Store, that you can plot the graph of y is a brackets x minus h squared plus k, that means the vertex form, and try to see how the values of a, h, k affects the shape of the shape of the parabola. So the most important thing I would like to remind you at last on this page will be, so no matter its standard form or vertex form, the value of a, they're the same. So like what we mentioned on the right column, if it's 2x squared plus 5x plus 2, after several steps, so the value of a should be the same, which is 2. The vertex form plays a very important role in studying quadratic function because it gives us the very important value which is called hk, which stands for the vertex. So it is very important because it's not just giving us a point. For example, like in a happy graph, the minimum the vertex is hk here. But besides it tells us the minimum point, it also tells us the minimum value of the function, which is a k in the diagram. It also tells us the S of the symmetry, which passes through hk, which is equal to x is equal to h. So in this situation, we've got two and other important information. So even if it is an happy graph, which is a parabola opens upward, so the vertex is also hk. So the difference is this time the point becomes a maximum point, which tells you the maximum value of the function is value k. But the S of symmetry, there's no difference, so it's still x equal to h. In the coming 2 pages, it tells we will try to see how we can read the information from the vertex form. So let's start from example 3. The most important thing about vertex form is it's not in a very good looking indeed, because it's a times x minus h squared, but the latter part will be plus k. So you have to make sure that the symbol should be in the form of minus in the brackets and plus outside the brackets, so that you can read the value of vertex from the diagram, from the function carefully. So now we come to example 3a, which is already in a very good format because it's like minus and plus already. So according to the question, I just need to find the vertex. So that's why the vertex can be written or find very easily, which is equal to 1, 3. But starting from part B, so it's a bit different because, wow, you see it's plus here. So if you're smart enough, you know the h is minus 2. If you're not very smart, fine, you'll write one more step, because if it's plus 2, we read it as x minus negative 2 in the brackets. So that's why the vertex now becomes minus 2 and 1. So can you spend a few minutes or even 1 minute to part C and part D? So let's pause for a minute. Alright, so part C, you've got y is again, so you see, so the symbol plus and minus is not fitting to the format of Vertex form very well. So that's why we write it as 1/2 x minus -3, bracket square, and plus -6 if necessary. So you can skip this step, then you jump to the answer, write down vertex is equal to -3, -6. Part D, so how about I just skip a step to write the answer directly, which is vertex now it is -1/2 and also -5/2. So hopefully it's a piece of cake to you on reading the vertex from a vertex form. Now I give you another task. Can you help to sketch the diagram to each of the question respectively? What I mean is, can you draw is to determine whether the graph is happy and unhappy, and also the vertex carefully. Alright, so let's start from part A. Vertex itself, not vertex, wait, let's start from A first. So this is the number we always overlook because in vertex form we just like copy from the question. So oh no. So first of all, in part A, so you see the value of A is 2, which means it's a happy graph with the vertex 1, 3. And so where is the y-axis? Because it's 1 here, so that's why the y-axis should be on the left-hand side. And because it's 3 here, so that's why it should be right above the x-axis. So the diagram will be more or less like this one. Now, can you take a few minutes to try part B, C, and D respectively? Let's take 3 minutes to do so. Okay, time's up. This time is a 2 again, so that's why it's a happy graph. Vertex is -2, 1, so which means the y-axis on the right-hand side, 1 for the vertex, so that's why it's above the x-axis. This is the diagram for part B. And next, no space, so let's take a look in part C. 1/2 here, happy graph again, -3, -6 for the vertex, so which means the y-axis should be lying on the right. -6, that means it's below the x-axis, so it is an approximate idea picture of part C. Part D should be similarly, oh no, because A is -1/3 this time, it's a happy graph with the vertex -1/2 and -5/2. Okay, because of -1/2, which means the y-axis should be on the right-hand side of the vertex, -5/2, so which means the x-axis should be above it. So these are the pictures of the graphs of the functions in part A to part D. The next example tests you or teaches you some ideas of some special terms, including optimum value, vertex, axis of symmetry, etc. So before we start the question, because we have got two formats, one is called standard form and the other one is called vertex form of a quadratic function. So that's why when you start reading a question, you have to determine which form is given in the question. So can you identify example 4 is written as AHK form now. So it's called y is a x minus h squared plus k. So this is the first task. You have to study the question very carefully to judge it. Now can you take a few seconds to identify what are the values of a, h, and k in the question? You've got 10 seconds. Okay, so answers are a is -2, h is 1, and k is 1. So now we come to look at what's the meaning of optimum value. Optimum itself in math, it simply means you are talking about maximum or minimum value of the quadratic function. So that's why you have to know whether it's a happy graph or unhappy graph to judge whether it's there is a maximum point or minimum point. So according to the question, a is -2, so you have an unhappy graph with h is 1, h is 1, k is 1. If necessary, you can add the x-axis, y-axis to help you, or else you just read from this diagram. Optimum value is not 1, 1, so it's totally wrong because we are not talking about the vertex. Because vertex you see part B, so vertex is 1, 1 in the question. So you don't expect part A will give the same answer. So what is the optimum value means? It actually means the maximum minimum value which is mentioned. So according to the diagram, so let's add the x, y-axis for help. Is 1 here, so that's why y-axis on the left hand side is 1 here, so x-axis should be below it. So what do we mean actually by optimum value? It means, so what is the maximum highest value of this parabola? Can you read this value? Yes, it comes from the y-coordinate, and it comes from the y-coordinate of the vertex, or that means the value of k. So that's why part A, instead of writing vertex directly, which is wrong, but we will say optimum value is equal to 1. So to be more precise, I suggest you to write not just optimum value, but you can also write maximum value in this question. So this is the first part, telling you or what's actually the optimum value means. Next, vertex is a piece of cake, hopefully. But what axis of symmetry is? Do you remember it? It is just do. So you pass it through 1. So 1, is it just 1 only? Definitely not, because 1 itself is just a number. We are talking about axis of symmetry, which is a line. The line itself is vertical, so that should be x equal to in the question. So don't forget it. It's a mistake you made a lot in form 4. So let's add the wording here. So it's called axis of symmetry. So S. Okay, that's all for example 4. Okay, so now comes to another example. So once again, study the question first. You will see so the following diagram shows a parabola. So that means it's quadratic, of course. And you see the format here is HK form. Again, you take a few seconds to identify what is A, what is H, and what is K. A, so this time is missing, so that means it's 1. H, be careful that there's a trap plus 2 here, so that's why H should be a -2. K, so it's not given, so you can just K is K, so which is an unknown we are going to find here. And the next, the question itself is also tells you the y-intercept of the graph is 5. A very common mistake we always find in students' work would be they will write K is 5 directly. So of course it's wrong, but do you know why is it? It's because some students miss so what shall we say? They mix up the format of y is ax squared plus bx plus c, because they remember that c itself, it means the y-intercept, that means it's 5. So that's why they mix up with the k, the value of k here. But the problem is, as I mentioned right now, because now we are talking about vertex form. So that's why the k here, it doesn't mean that the y-intercept nor the value of c. So that's why it doesn't help you to get the answer A1 so quickly. So as a result, what shall we do? And then now it goes back to a very common concept I mentioned to you. Y-intercept 5, that means sometimes we need to consider 0, 5 for a particular point. And if you have a point and you want to find unknown, what shall we do? Do you remember the method we always mention, or I always mention? Yes, do substitution, because it's an unknown in the graph. So that's why the way to do so is not just simply wrongly put, say in that case 5, but we are talking about putting 0.05 into the function, which is called y is x plus 2 squared plus k. And then because simply is we are finding an unknown in the diagram. So let's take a very quick calculation. 0 plus 2 is 2. So that's why we've got k is 1 very quickly. And so we finished the first one. Second one is, now you see is talking about minimum value of y. Can you find that it's very like asking optimum? Can you find that it's very like finding optimum value of the function? Indeed, they are asking the same thing. So that's why in order to do part 2, see if it's necessary for you to rewrite the function again, called y is x plus 2 squared plus 1 that we obtain in A1. Now you can go back to the little remark we do in the previously. So we've got a is 1, x is minus 2, k, now k is 1. So that's why you can write the vertex. Vertex is part B. Okay, maybe we do it first. Vertex is what? Is minus 2 and 1. So this is the point. That means the point minus 2 and 1, which is the minimum point in the diagram. And according to this minimum point, you can see the minimum value of the diagram. It reaches the value of 1. So that's why in A2, we've got the minimum value of y. That means the function, the diagram, it is equal to 1.